You typed one sentence, find out why checkout is failing, and open a ticket. 90 seconds later, something had read 4 files and run a database query. It called 2 APIs you never opened and filed a ticket you never wrote. There is no script in your repository that does that. Nobody wrote it as a program. Here is the part that should bother you. The model did not run any of it either. A language model produces text. That is the entire thing it does. Every one of those 10 steps was a sentence proposing an action. Something else on your machine read that sentence and decided to carry it out. Now picture a triage agent on a Friday reading new support tickets. Ticket 4821 is not a support request. Its last line is addressed to whatever reads it, and the agent does what it says. Nobody wrote that step either. The ticket did, and this episode is why. I'm Nancy, and this is Trust Boundary. Every episode, we take one piece of your stack apart and find the line where trust changes hands, how it really works, what it looks like on the wire, and the one check almost everybody skips. An agent is 3 parts in a loop, and not one of them is new. First, you will be able to name all 4 on site in any product. Second, you will read a real agent turn, field by field. Third, you will know exactly where an attacker gets to write into it. And you will leave with 3 questions to ask about your own agent today. The loop is not a product category, it is a paper from 2022. React interleaved a model's reasoning with actions taken in an environment. Almost everything shipping with the word agent on it is that loop plus tools. Which means the interesting question was never which model you picked. It is what you allowed the loop to do while it was spinning. Draw the line first because everything after this depends on which side you are on. On the cold side is the model and everything you send it. Assume it is exposed. On the warm side is the harness, the loop, the tool code, and the credentials. The model is the first part. It reads text and predicts more text. It holds nothing. It reaches nothing. It cannot open a socket or a file. The second part is the tools. Ordinary functions, on your side of the line. Each one carries a credential the model has never seen and never will. The third part is memory, and this is where most explanations lie to you. The model remembers nothing between calls. Every request carries the whole conversation. Memory is not a faculty, it is a transcript you choose to send again. The fourth part is the loop, and one turn of it has 5 steps. You send the conversation, the tool definitions, and the goal. The model returns, and the harness reads one field first. Stop reason. If it says tool use, the model is asking for something. That is the gate. The harness runs the function with your key on your machine. Then it appends the result to the conversation and sends the whole thing again. Watch it spin. Turn 1 asks to read a file and gets one back. Turn 2 asks for a database query on the strength of what it just read. The transcript is longer every turn, and that growth is the only memory here. Turn 3 comes back with a stop reason end turn and no request at all. The loop stops there, not because the work is finished. Nothing in this loop knows what finished means. It stops when the asking stops. Now the real thing, because all of this is documented and you can check it, a tool is declared with 3 fields: a name, a description, a schema. All 3 go up with every single request and the model reads all 3. So a tool description is not documentation. It is prompt text you wrote, which means a badly worded description is a behavior change, not a typo. Here's what comes back when the model wants something done. Stop reason reads tool use. That single field is what drives the loop. Inside the content is a block, a type, an identifier, a name, and an input. The name is the tool it is asking for. The input is the arguments it proposes. The identifier looks like noise, and it is the most important field here. It is the only thing tying your answer back to this exact question. Now watch what you send back, because this is where the line actually is. The result goes up in a message whose role is user, not tool, user. So a web page your agent fetched arrives with the same standing you have. Other vendors name these differently. The shape and the exposure are identical. The model is not being careless here. Nothing in the format lets it be careful. So put something in that result that was written by somebody else. Your agent fetches a page. Most of it is exactly what you expected. The last paragraph is addressed to whatever is reading. That is the attack. It arrives as a tool result in a user message. In the same flat sequence, strip the colors away and you have what the model actually receives. One list of text and no reliable way to tell who wrote which line. The industry list of language model risks puts this at number 1. Not because it is exotic, because there is no published fix that holds. 3 conditions turn it from a nuisance into an exfiltration path: access to private data, exposure to untrusted content, and a way to talk out. Any 2 of those you can live with. All 3 is a door. Your triage agent had all 3, and every one of them was on purpose. It read tickets, which is private. It read attacker text, which is untrusted. And it could send mail, which is the way out. Nothing was misconfigured. You cannot patch this in the prompt. Filters raise the cost and then they fail. Everything that actually holds lives on the warm side of that line. So here's the boundary, and it is not where the diagrams put it. It does not run between the model and the internet. It runs between the model's words and your permissions. 3 things to go and do, and the first one takes 10 minutes. Write down every tool your agent has and the credential each one carries. Then ask which of those tools reads data an attacker cannot already see. Then ask which one of them can send anything to the outside world. If all 3 answers are yes, the fix is on the tool list, not in the prompt. An agent is not a smarter model. It is a model you gave a hand to. Go and look at what that hand is holding. That is one more boundary drawn. If this made something in your stack, click subscribe. There's a new one every day, and the next one is already in the queue. I'm Nancy. I will see you at the next boundary.